Morning, Ananda Prasad here. I'm here to explain the concept, that is convolutional neural network. Before discussing about convolutional neural network in detail, let us see some of the important concepts in machine learning and deep learning. Actually, what is machine learning? Machine learning deals with algorithms to handle huge volume of data. Here, machine learning is a part of artificial intelligence. Similarly, deep learning is a part of machine learning algorithms. So there are so many pre-trained networks available. Deep learning algorithms mainly focus on neural networks. There are several pre-trained networks available. One of the important neural network, which is mainly used for practical applications which deal with image and huge volume of data, is convolutional neural network. It can also be termed as convolution network. It deals with mainly grid-like data. The data may be of it may be a one-dimensional data like time series data, or two-dimensional data, image data, and it also deals with multi-dimensional data. So mainly convolutional neural network is used in many practical applications. It indicates that the network employs the mathematical operation called convolution. What is meant by convolution? That we are going to discuss in detail in the upcoming slides. So this convolution operation is an operation on two functions of their data. Suppose we track the location of a spaceship using a laser sensor. It will give you the output as if it gives you a single output at a particular time period t, where exactly the spaceship is located. That data will be given in x of t. X is the position of spaceship at time t. In case of sometimes the data may not be clear. The data may be noisy. So we have to calculate the average of reason measurement. Reason measurement means we have to calculate in continuous time periods, and we have to take some average value among the values. So more reason measurements are more relevant, and it can be a weighted average. Instead of calculating normal average, we will be using weighted average method that gives more weight to reason measurement. See, this weighted average is denoted by the symbol W of A, and it is called as weighting function, where A is the age of measurement. Age of measurement means at a particular time period. At say for example, time t is equal to 10:01. We will be taking the value of exact location of the station. That value will be stored in A, and provide a reason function which uses the following equation. So using this equation, we will be calculating the exact location of the spaceship. Integration of x of a, w of t minus a into d. W is the weighting function, x gives you the exact location, and we have to find integration of this value. The limit may exceed, that is, we can change the limit. Finally, we will get a value s of t, which will give you a smooth estimate. Okay. The convolution operation is mainly denoted by the symbol asterisk. S of t is equal to x asterisk w of t, at time t, x into w. And let us see an example in the next slide. So w is a probability density function or output which cannot be a weighted average, and it should be 0 for all negative elements. We will be not considering the negative values. We will be considering only positive values. So the important terminologies used in CML are input, that is the first argument to the convolution is the input, and the second is the kernel. Input is what we are going to process, that is the image, the data, which may be in any form. It may be a one-dimensional data, or it may be a two-dimensional data, whatever it may be. The data is considered as input, and another one, second is kernel. Kernel is also a two-dimensional or a multi-dimensional matrix, it is a multi-dimensional data. In case if it is a two-dimensional data, it will be in matrix format. There will be normally we will be choosing 2 cross 2 or 3 cross 3 matrix as a kernel value. So after processing, that is after using this operation convolution over the input, we will be getting our output as feature map. Okay, the feature map consists of several feature values. So in our example, the example what we are discussing here is the location of identifying the location of a spaceship. So here the idea of a laser sensor that can provide a measurements at every instant, it may not be realistic. So if you are using, when you operate the data on a computer, the time will be discretized. At a particular time duration, we will be calculating, we will be taking the values of the spaceship and we will be taking some average value or something like that. That operation is defined as pooling actually. That any operation you can take, either you can use max pooling or average pooling. Several types of operations are available. Next one. Here, this equation here, at time t, s of t will give you the location. So from minus infinity to plus infinity, we are taking the summation x of a to w of t minus e. Here at time t, we are calculating the location value. So for that, we will be using the previous values. Previous at particular time period. Say for example, if you are starting with t as 0, then after some time period, t is equal to 5 or something like that. If you want to calculate the value, then we have to take the previous value also. So in discrete intervals, we have to calculate the convolution values. Mostly we will be using integer values. We won't use real values. So what is meant by tensor? So in machine learning applications, the input is usually a multidimensional array. As I said already, the kernel is also a multidimensional array of parameters that are adopted by learning algorithm. For which algorithm? That is, if in case you are going to write a separate algorithm, then you can design your own kernel. This is referred to as the multidimensional array is referred as tensors. So each element of the input and the kernel must be exactly stored separately. So we will be operating, that is, consider for example here you are having a 2 cross 2 matrix and this is your kernel. We will be placing the kernel over the input periodically and we have to convolve. We have to convolve the values in the kernel along with the input values. That example will be given in the next slide. So this is the equation used for that. So here is the example. This is your input matrix. This input matrix is a 3 cross 4 matrix and the kernel is a 2 cross 2 kernel. So initially we will be placing this kernel. Just imagine we are placing this kernel over this 2 cross 2 size portion of the input. So we have to multiply a into w plus b into x plus e into y plus g into z. This is stored separately. This is your output. So finally, again after performing convolution over the first set of 2 cross 2 matrix, we have to place the kernel here. So B, C, F, G. Then B, C, F, G. We have to process the convolution over the next set of 2 cross 2 matrix and then we have to move on to the next set. Likewise, we have to continue. So initially, if you start with 3 cross 4 matrix, finally you will get 3 cross 3 matrix. 2 cross 3. The size will be reduced. If you want to retain the size, see initially if you have 3 cross 4, then if you want to retain 3 cross 4 as output, then you have to include padding. That is 0 padding or something like that. You have to use padding pixels. Then you can retain the size. The size may not change. Okay, that is the example given. Mainly, this is used to identification of edges in images. An example is given here. So, what can see here? You can see a dot. Here, after performing convolution operation, you can identify the edges clearly. This is an edge detection algorithm. And some of the connectivity exists in neural networks. There are 2 types of connectivities available. One is sparse connectivity, another one is dense connectivity. sparse and dense connectivity. So, I move on to the next slide, sir. Please.
Sir.
So, you can see this is an example for sparse connectivity. Here, 5 neurons with X5 inputs. These are not, we are not connecting all the values with all the neurons. See, only with few neurons we are connecting. This is an example for sparse connectivity. Next one, dense connectivity here. See, we are connecting each and every neuron with other neurons. This is dense connectivity. Example for dense connectivity. Another important concept in deep learning or convolutional neural network is parameter processing. This is very, very important. See, we have to mainly to evaluate the performance of our algorithm. We have to use so many parameters. So that is different. That parameter is different from parameter sharing. This is parameter sharing within this model, neurons. So in CNN, the kernel is matched in every place, hence it is called parameter sharing. The kernel matching is itself is defined as parameter sharing. Okay, in case of sparse connectivity and in case of dense connectivity, how the parameters are shared is defined. Shall we wind up the session? Thank you.